Okay, everybody. Sorry for that little technical delay there. We are up and back running. We'd like to welcome you all back to Inclusive Design 24. We are brought to you in partnership with Barclays Access, the Paciello Group, Intopia, Microsoft Edge, and Open Access Technologies. Don't forget, if you like what you're seeing, please subscribe to our channel by hitting that there subscribe button. And do not forget to follow ID24Conf on Twitter. If you have any questions for the presenters, please tweet them using the ID24 hashtag, and we'll ask them at the end of the session. We're doing this one a little differently because our presenters are having some trouble and they can't hear us talking. So might be a little glitchy at the start, but that's okay.
Hello everybody, I think we're live and unfortunately our signal keeps dropping here in Dublin. Yesterday for the test with Tim, everything worked perfect, and of course when we go to do it live, everything goes a grumble. So I hope everybody can hear us now, and we're going to get started. Sorry for the delay and anybody who's been online waiting for us. We do apologise for the delay in getting started today. We're so excited to meet you all and following you all on Twitter. Congratulations to everybody who's been involved in ID24 and to all the everybody who's involved in getting it together. So I'll just share my screen now and we'll get started with the presentation.
So hello everyone, I'm Damon, and you've seen Barry and Sarah in the pictures earlier on, so we're just going to get into the presentation now. So we're basically talking about this responsive microwave that we've been working on for a little while now, colleagues from our own school in Electrical Electronic Engineering at DIT, and from the community, the John God community in Dublin. And you can see on the right-hand side of the slide there was a reasonably varied team of people who worked on it, including a whole number of undergraduate students who helped develop different parts of the project. We're going to go on and do a short set of videos now to give you some of the backgrounds to the project.
Thanks, Damien. So my name is Sarah Bowens and I'm the Assistive Technology Facilitator in St. John of God Community Services. And I get the great job of working with people with an intellectual disability and matching them up with technology that can support them to be independent. So Barry's here with us today and he's made a short little video just to introduce his involvement in the research project. And we were very honoured to have Barry as part of the research team. He went through every step of the project from getting ethics approval, going into the meetings and everything. So we're very honoured to have Barry as part of our team.
Hello, my name is Barry Crine. I live in Dublin, Ireland. I was involved in a microwave project with Matteo. The idea came from the lads when they're dropping. Our staff, Alan Byrne. We made a video to show the students what we wanted.
Hello, Cook. We have a problem with the microwave.
There's lots of buttons.
High, low, defrost.
Flash them numbers.
We can't read the instructions.
This may be a mad idea, but there's no harm in asking.
Could we have the scanner here and display here?
We can scan the barcode of the food.
Display can give us instructions.
The timer will automatically set. Who would upload the information?
Maybe the users.
Fabi.
Refreshable carers.
We made a video on an iPod. All the students saw the video and they liked it. Some students want to try and make it. Mateo and Modestus and Adrian helped us with the microwave. I was on the research team. I went to all the meetings. We asked a lot of people what they want on the microwave for a good idea. Built a lot of prototypes. We tested it out with a couple of lads on the drop-in club. Every user has helped us out with the microwave. We tested it out with people in wheelchairs. We tested it out with people difficult using numbers. We tested it out with people who can't read instructions. It was hard work, but it gave us good ideas. We worked with different people building the microwave. We got a good ideas from the lads with really good idea. I like to be in the research team. I like talking about the project. I like to be involved in more projects like this. I like to make more stuff that people can use. Everyone can use. But it's important to be involved in making a microwave. It is important we involved in making things. It means we can use the microwave. We can be independent.
Video sent around 2 other students, and the DIT students and Damon especially decided to pick it up and actually start to build the microwave and to work out a research group to see how the microwave could be built.
If I could just say, I mean, we received that video, and it's quite a powerful thing to be receiving. To actually, it really motivated us to try to answer the challenge. And I think it's a really excellent way to start the project. Very impactful.
So, in order to build the capacity of the men and women who we support, we needed to go through a process with them. So, the men and women who we support on their daily basis wouldn't normally get the opportunities to build for themselves, to create support tools for themselves. So we needed to really kind of fast track that process and to give them the understanding of what it was to design something, how to ask questions, how to come up with ideas. So we used the design thinking model and how they also had to have empathy towards the students and towards the engineers, because they had come up with this idea, this very kind of idea of the what ifs and them using the TV screens and scanners and that. But they had to realize that there has to be a design process in place so that overnight, I suppose, Damon and the team in DIT couldn't just click their fingers and make it all happen. So we had to, I suppose, make sure that the men and women that we support who were involved in this process, that they were mindful of that and that they knew that there was a process they'd have to go through. The ideate as well was a really important stage of that. They had to be able to come up with ideas, be able to work at prototypes and know that what a prototype was, how it can be used and how it can represent what the final product's going to look like. And the testing phase, even to give them a bit of background information of what is testing, how do you test something, how do you ask questions, that you don't just tell Mateo or Damon what they want to hear, that you're brutally honest with them. I think Damon would agree. So yeah, it was just to really upskill the men and women in the creative process and ensure that they really felt like they were co-designing these products and that it wasn't just tokenistic and that they were involved in the process every step of the way.
Okay, so I'm going to take over now for a little while. Just coming back to, the backgrounds of this, I suppose, there's development of technology all the time. There's the whole app revolution and, the Internet of Things and all of these different things. And, as taking the sort of the engineering side of things, there's so many possibilities there. And this is against the background where care processes are changing. Care is moving from hospitals into the community. In Ireland, we've got deep congregation, and that's been ongoing for quite a while now. And there's this whole idea of placing the health service into homes, and then trying to ensure safety and security and independent living within homes. So to address these things and try to support them, we can try to mobilize the technology to try to help people to live independently and to have fulfilling lives. Is it this one? Yeah, okay. So one of the main activities of daily living, of course, is the preparation of meals. And the challenge that was issued in the video that you saw there was issued to us, and we decided to try to take it on and to try to find a way to allow the community in John of God's to work themselves to support other members of the community in preparing meals. So we were trying to find ways to develop this community-supported appliance, a microwave that would help the user in cooking or develop or basic meal preparation. Started off with a barcode of the product. Okay, so it's typically for processed foods. It's not going to be for an apple or something, but something where there's a package there that you can scan the barcode, and that kicks the process off. And then the person is guided in an interactive way through the steps in preparing that particular product. As background to the thing, Matteo, who was the primary mover in this, did a preliminary survey looking at the interfaces for microwaves, and it was quite interesting to see some of the outputs of that. So, for instance, the number of buttons, there's just a proliferation of buttons. I have to say for myself, I find microwaves a challenge. I'm willing to admit that. I mean, typically you could say that there's probably only a need for 2 or 3 buttons on a microwave, but somehow they seem to just have 20 or 30, So, Matteo's initial study showed that the average quantity of buttons on a set that he gathered together was 16, which seems like rather a lot. Okay, so looking at the interaction then with the members of the community, and there was a number of different actions that took place there. And Sarah, you might want to say something a little bit about that.
Yeah, I suppose because the idea had really come from the men and women, we wanted to ensure that they were going to be involved every step of the way, that it really was going to be co-designed. I suppose from my own experience in the past, I had tried to develop an app in the past, thinking I'd met with some of the men and women from St. John of God's when I was a volunteer. I'd done a few interviews, I'd sat down with them a bit, I talked to speech and language therapists and OTs. I thought I'd generated a quite good requirements document. I went back to build the app, and then I found that when I went back to test it with the users, I got it so wrong. Back to the drawing board, and a year later, but what I did the second time around was I didn't move on step forward without the users being there every step of the way. So I think I learned the hard way about how important co-design is, especially if you're designing for accessibility, that the person has to be there every step of the way. So that's what I wanted to ensure with these projects. And we were very lucky in meeting with Damon and the people in DIT. They were like-minded, and they wanted the men and women who we support with an intellectual disability to be there every step of the way. They valued their opinion, their ideas, and their input on the project.
And I think that the process itself has its own value. I mean, even if the artifact is a prototype, the people who are involved in the process actually get a huge amount of value out of it. And that's quite apart from the supposed end product of it. And I think, that's something you really have to take into account when you're looking at these things. I mean, there's a fair bit of organization involved in doing it, but when you see the participants and see how they progress over time on both sides, it's really, really worthwhile.
Yeah, it's a definite win-win for us. So the men and women who we support wouldn't have the opportunity to go to mainstream universities or colleges. Those affordances are just not there for them. They just wouldn't be able to do it. So this is where they're going into DIT with their head held high, going around the canteen, meeting with the students. Even I think Barry, you met some of the students on the Lewis a couple of times and stuff like that. So it's that we really are opening up the men and women who we support world and making it far more inclusive. And I think DIT, likewise, even the students in DIT, from when the first time we start working with them on the co-design projects, whether it's the computer science or the engineering students, by the end of the process, they're totally different people, which is really good and much more inclusive and engaging and just better overall for society.
Okay, so coming out of this, of course, there's the usual, the input that you get into the next stage in the process, and we try to evolve the different user interfaces and so on as part of this process through interaction and through questionnaires and various other mechanisms.
And these are some of the questionnaires that Barry actually went back, and we made an accessible questionnaire. Barry went back to the various different services and gathered these results.
How does the capable microwave provide cooking assistance? Okay, through gamification and through icons and animations. And we'll talk a little bit about the evolution towards that in a minute. So there are two core elements, I suppose, in terms of the interaction. One is the suggestion, where you guide the user through the steps in the cooking process. So for instance, open the door of the microwave, put the product into the microwave, that sort of thing. And the second thing is when something happens, alerts and timing and so on, events that actually make the process run along. So I suppose for those computer scientists around, there's a kind of a state machine element to this, okay? But the alerts then provide a number of different levels. One is to take when a step is finished, but also things for safety. For instance, if a smoke alarm goes off, for example, you might want to have an override.
I think it's fair enough in saying, Damon, that there's a number of those steps that both the engineering and the computer science students wouldn't have even thought of. If the men and women.
Yes, and that's obviously an important part of the design process, that you're getting those insights. One thing, for example, is the tendency for people to actually, when they're familiar with a step, to skip the step, and for the system to be able to deal with that. And that's how we introduce, for instance, things like door sensors. We'll come to that in a minute. And so just in terms of the basic system, we have a microwave, and there are objects to interact with it. And so what happens is that the user wands or barcodes the product, the packaging for the product, and the barcode is sent up to the cloud, and then back comes a set of multimedia instructions. Okay, I'm just going to continue then. I hope that's okay. And the resources for the interactive cooking instructions come back to the microwave, and then those things are played, and the system interacts with the user. So sorry, there was a phone call in the background there. So those set of instructions on the cloud are actually are created then by the community, and this is a really nice aspect of this. So for instance, you can imagine a group in maybe something like an OT session could be working together and talking about how to cook noodles, and try to think about those ideas. How can you gather that information and then provide it to the users at a later stage? That's an interesting challenge.
Go for it.
Okay, so this is some pictures of the system. This is the thing where the user will actually be using. You can see there's the touch screen on the right hand side, and there's a barcode reader on the top here, and here's the microwave. And there's wires hidden in here to control the microwave in the background. We'll see a little bit more about that in a minute. Now, we're not going to hear this video.
You're not going to hear it, but you might be able to see the
in action. Yes, that's a point.
See Barry, actually, this is just on the RT and Irish news channel. But what you should be able to see in the background is you may be able to see Barry using the microwave.
The five-storey building cost €17 million to complete and is home to 12 specialised labs, office space for 136 people, meeting rooms, and incubation and commercialisation space.
Our research is very purpose-driven, and it's about producing new innovation that can be used, and we want a causal route by which new businesses are formed that employ people and bring society forward.
Move the plastic.
Others are working with service users like Barry Cryan from St John of God's Community Services to develop a smart microwave. It uses multimedia to help people with various levels of ability prepare simple meals.
And we're scanning the barcode of the packet, and then on a LCD screen monitor, it will show you step-by-step video instructions of what you need to do to cook that.
Okay, so in the background then we have this capability where we can gather information from a group session where people talk about cooking a particular product, which I think is useful in its own right. And we try to gather that information, make some resources that go with it. So the nature of those resources is another interesting issue. And we gather that content together and store it in the cloud. And then the idea is it's linked to a barcode, and then it can be downloaded to the microwave.
Great. So, yeah. The potentials are endless, really. If we had one of these in every one of our residential homes, we support, there's 20,000 people that St. John of God's support in Ireland. With people with an intellectual disability, you're talking probably about 3,000 or 4,000 people. Of them, a lot of them will be in residential home who are just continuously relying on staff or family members to support them on a basic thing of taking a ready-cooked meal and to put it into the microwave. So that's where I suppose it all came from. So the potential is endless. If this microwave, if we could get it into production, that would be the big dream.
To further develop such a system, and that could be universally designed and a functional smart environment for everyone's home. Now, we are conscious that the use of barcodes could have limits, and we did debate the idea of whether it should be a handheld scanner or whether it should be something on a phone, or should there be another mechanism to recognise a product. It could be using a camera to recognise a product. And those are all open issues, which I think are all compatible with this idea. It doesn't have to be limited to using a barcode. But we did say that for the scope of our project that we would focus on processed foods. So we were specifically not including in the scope of what we did unprocessed foods such as egg or porridge or meat, just in the sense that was actually moving beyond what we'd intended. Disability, for many citizens, senior citizens, for example, some of the simplest tasks, such as cooking in a microwave, can be difficult. So, written instructions and so on for given different types of products could be variable, and you need to have remember which setting is appropriate for each one and so on, and then just interacting with the complexity of the microwave. So these are all things that are worth considering, and we see that there's a possibility here that this idea could go, to a fairly broad population, and it could be used for designing a new interactive way of safe food preparation. So first of all, I have to say that I wouldn't recommend working to modify a microwave in the way that we have done it, unless you're qualified to do so, like an electrical engineer or electrical practitioner. Microwave parts such as the magnetron can be extremely dangerous, so you just have to be careful about opening up the back of a microwave. For our part, we were keen to minimise our modification of the microwave, so the one that we use in this project. So basically what we did was we looked at the circuit diagram and we added in a 12-volt relay that controlled the magnetron, the carousel, the lighting and the beeper all in one go. It was very simple. We just cut the wire, put a relay in and controlled it from outside and closed up the microwave again. And that was a way of just dealing with that issue. I think if you're going to do anything more, you can make it much more performant by actually individually controlling those four things separately, and that would make it interesting from a usability point of view. But I think for the purpose of demonstrating, what we did was fine. I've previously mentioned the idea of the icons and animation and dealing with it, and we'll see some examples of that in a couple of minutes. But other features in relation to feedback to the user were, first of all, sound. We were able to record sound from various members of the community and then play them to the microwave user through an audio speaker connected to a Raspberry Pi. The Raspberry Pi also had a touch screen, a standard Raspberry Pi touch screen, which used, for those who are interested in this detail, the Kivy library for Python to allow touch interaction of the screen. And that touch was enabled the basic transition between each cooking step. Now, in a second iteration of the prototype then, we added what we call context sensors to detect, for instance, the opening of the door in the microwave and the closing of the door, to detect weight changes when a product is added to the microwave or removed from it. And also, we had a separate smoke alarm which was wirelessly connected to the device, and we'll come back to show how that was architected in a couple of minutes. So I mentioned the animations and icons, and before we showed some of the screens that were developed, just to say that when we did the first version, we used video versions of icons, video with sound, voiceover, all in one file. However, when we tried looked at downloading that information to the Pi, we found that the download times were quite slow. So for that reason, we moved to black and white icons, which were each paired with short audio files for each step. Sarah can talk a little bit about the reasoning behind using the black and white icons. The image files were each discussed in a couple of iterations through the co-design process with the service users and with their ideas for the best imagery, to try to develop ones that everyone could understand and relate to. And the audio files, of course, were also, as part of the process, devised and recorded by the members of the community.
I suppose it was really important that the feedback was going to be accessible for the men and women. So we followed the best principles of total communication, where we were displaying both text and audio and an image that they could relate to. When we tried it with actual real images of the product, if it wasn't the exact product that they had bought, so for example, there are multiple different types of popcorn, if it wasn't the exact same packaging, we found that some of the men and women were getting confused. So that's why we simplified it down. Even introducing colour sometimes could also distract from what the task was. So that's where, through a number, as Damon has already mentioned, through a number of different testing sessions, we realised that actually the black and white icons seem to work best for this community.
I mentioned context sensors in the previous slide. So this slide gives a brief overview of that part of the system. And this piece of the work was implemented by an undergraduate student. So each of the three context sensors was implemented by connecting them using a bean. This is a wirelessly controlled and embedded system. It's like a fancy Arduino, I guess. It's based on the Intel Curie boards for those who are interested. So these beans have full Bluetooth LE low energy functionality and allow them to act as Bluetooth low energy peripherals. And that means they can communicate wirelessly with something like a Raspberry Pi, and they can provide information that can be then picked up by the Pi, which is acting as a Bluetooth low energy central device. So you might ask me, why that complexity? Why not just wire the sensors directly into the Pi? And that would be relatively easy to do. It's not simpler thing. But one thing we were seeking to explore with that idea is that you could have sensors all around the microwave, not just on the microwave itself, but in the surrounds of the kitchen or whatever. And that, for instance, if someone opens the door of a press or opens the door of a refrigerator, that information would also be included and brought into a rule base or whatever. So it's just it's a thing that we sought to explore, I suppose. Okay, so now we're going to go down another level of technical detail. Here's the UML diagram. It's a class diagram representing one version of the cooking instructions. And this has been implemented, this particular model has been implemented both in a database in MySQL and as a JSON message format for communicating between the cloud and the microwave. And you can see that there's quite detailed stuff here. You've got meal prep instruction sequence, and that contains multiple instruction steps, and those instruction steps can be either a user instruction or a device instruction and so on. And that's all great. And I mean, people with technical background in computer science or in engineering live this stuff and they know it. And UML is widely used for design, but it's not really conducive for co-design in many domains. It's not something that you can reach out to community members with and allow them to communicate and to design and to work together on. So although UML is a domain-specific language, in other words, a language that is in the idiom of the users, it's not our domain-specific language. So it's something that we need to, it's useful for maybe detailed work, but for the co-design part of it, it's not really all that helpful. And here's another piece of it. This is a state diagram showing transitions between steps in cooking instruction steps. So, I mean, again, this is, for someone who's not familiar with this nomenclature, it's hard to get into. So, looking at those representations, I think it's important to go back to think about what a domain-specific language is about. So, a domain-specific language provides simple and concise representation and it expresses these things in an easy-to-use notation. And Fowler, who wrote a book on the topic, said a DSL should be explained and expressed in the idiom of the users. In the idiom of the users. In this work, then, a DSL should enable users to create and develop sets of cooking instructions for an automated or semi-automated process in an engaging and efficient way. And it needs to be designed, in this case, for a microwave oven, and of course you could extend it out for other cooking appliances or indeed other parts of the home. But the important thing is here, we wish to engage with groups of service users from St. John of God's. So UML clearly is not going to be the primary way of doing that. So the idiom here is a graphical idiom. We're representing the information as graphically and as vibrant a way as possible, and an attractive way as possible that reminds the service users of the familiar icons and whatever that they use on apps and on phones. So here's an example of some clear pictures of products that should be reasonably recognizable, and then you can see a plus sign showing on the app. Now, in fact, we'll see a little bit more about the evolution of that plus sign in a second. So on the left-hand side, you've got the plus sign that you saw on the previous slide, and when we actually, for example, in the code design process, spoke to the users about it, there was a comment that it looked very like the symbol for a pharmacy. So this was something that was confusing. It wasn't, the plus part of it wasn't represented strongly enough, I suppose. The green colour in particular was made it resemble a large group of pharmacies that are here in Ireland. So the idea then was to move away from that green cross and make a black and white cross instead. And here is a quick animation of some of the artwork that was produced during the project. Here are some screenshots of the OT screens for selecting a product to produce a new cooking resource. And you can see on the left hand side you're selecting a particular icon or image. And the right hand side there's a little bit more involved task of actually using a camera or something to actually get some information. I guess it probably requires, it's not completely usable on the right hand side, but it's trying to make it as accessible and as recognizable to the users, the OT as well as the service users, I must say, as it can possibly be. And here are screens for adding parameters to individual cooking steps. And again, you can see there's icons on the left hand side. In each case, there's a bit of text as well. But the icons, bear in mind that this is a group activity, so the icons can be used to try to concentrate people as member of the group about what they're trying to achieve in each of the steps, in each of the 6 steps there in terms of devising or deciding on the parameters. And I've deliberately left this little bit to last. This is the JSON, the JavaScript object notation format that we use to convey the instruction information from the cloud to the microwave. So you can see that JSON uses brackets to represent things being inside other things. So these are, you can see a number of different cooking steps there. There's 3 different cooking steps actually represented, and it seems to be, this particular example is for noodles. So, the information that's gathered in the graphical format of the public facing part of the DSL is actually then represented this way for communication to the device, and then when the microwave gets it, it represents it once again in a graphical interactive way. Well, that's all I have to say, folks. I'm going to pass you back now to Sarah, and she'll finish off, I guess.
Thanks a million, Damon, and thanks to Barry as well, who is here today, and all the ID24 team. So we're just going to finish off with just a little video that we made after one part of the process, and And this is a bit of feedback from all the co-designers. These are the DIT students and some of the men and women from St. John of God, and how they felt the whole process went. Thanks again for listening, and if you want to leave any comments down below, we'll get back to you.
2016, we done a partnership in DIT College. We wanted to build for co-design project. We came up with all the ideas, important projects, but real problems we have. The projects were number 1, accessible login, personal plan app, community life website. Number 4, easy cook microwave. There was 12 people that helped the students build these projects.
My name is Barry. I'm involved in the microwave project. Meeting new people. I like sharing ideas, making new friends. I'm looking forward to going to Cork next week.
The reason I picked this project was because it was community-based. I was a little bit tired of doing little projects that have absolutely nothing to do with the real world, nor did they help anyone.
Working on this project was different than working with other types of projects, because the main challenge here was not technical. It was on improving the usability to be universally accessible. So yeah, I hope to work on this type of projects more on the future.
Hi, my name's Ciara. I enjoyed going to town to the college. I went to town on the bus. I really liked going on the bus. The students were really nice. They're teaching us how to use the iPads. I was showing them what I wanted on the app, what different things and all. I would like to do more projects in DIT.
And so the kind of co-design, I suppose, had good advantages for everybody, for our service users. They were going out engaging with different people, and they also were putting their stamp on applications that would be used in their lives at a very basic level.
Well, it was really different because usually we just get a sheet of paper with do X, Y, and Z and have it done by a due date. But what made this project really different and actually a lot more enjoyable was meeting weekly with our clients, seeing what they liked, and we knew by the end of it that we'd have a really worthwhile project that they would love to do and it would benefit the community.
We hope to do more projects next year with new students.
Thank you again, everybody, for your attention, and contact details are below.
Thank you for thank you both, Sarah and Damon, for the talk, and I apologize for everybody who was involved. I know we had some technical issues. I think you two did a wonderful job trying to accommodate them, especially since we definitely had some audio and connectivity issues. And I'm glad you got to start to answer a question. That's always a great sign. I would just like to, well, we're not going to take any more questions, obviously. So if you liked this session, if you liked any of the sessions in reality, hit the like button, and don't forget you can subscribe to youtube.com/inclusivedesign24 for future notifications. And a reminder that Inclusive Design 24 is brought to you in partnership with Barclays Access, the Paciello Group, Intopia, Microsoft Edge, and Open Access Technologies, and with thanks to our sponsors, DQ Systems. Inclusive Design 24 will be back on the hour, and we will have, pardon me as I go check my list here, we will have Thomas Logan, and he will be presenting a talk titled, Let's Make Maps Widely Accessible. And my cat apparently wants to say hello as well. So thank you all, and we will see you in an hour. Cheers.
Thanks. Thanks.